Standard RAG follows a fixed script. Embed the question, retrieve the top 4 chunks, inject them into the prompt, generate an answer. This works well for simple factual questions. But what about a question that requires information from 2 different sections of your corpus? Or a question where the first retrieval returns nothing useful and a different query would do better? Agentic RAG gives the model tools and lets it decide what to retrieve, when to retrieve again, and when it has enough to answer. The difference is control flow. A fixed pipeline always runs the same steps in the same order. An agentic system runs a think, act, observe loop. The model thinks about what it needs, calls a tool to retrieve information, observes the result, and decides whether to answer or search again with a refined query. This loop continues until the model decides it has enough information. For simple questions, the loop runs once. For complex multi-part questions, it might run 3 or 4 times. The React pattern stands for reason and act. The model alternates between thought steps where it reasons about what to do and action steps where it calls a tool. After each action, it observes the result and decides what to do next. This pattern is implemented by giving the language model a system prompt that instructs it to think out loud before acting, and a set of tools it is allowed to call. LangChain provides a ready-made React agent executor that handles the loop automatically. We define the retriever as a tool using LangChain's tool decorator. The function name and docstring are what the language model reads to decide when and how to use the tool. The docstring is critical. It tells the model what the tool does and when to call it. A vague docstring leads to poor tool selection. A precise one helps the model use the tool appropriately. The function itself calls our existing retriever and formats the results the same way the fixed pipeline does. We create the React agent by passing the language model, a list of tools, and the React prompt. We pull the standard React prompt from the LangChain hub rather than writing it from scratch. This prompt instructs the model to think before acting, format its tool calls correctly, and signal when it has a final answer. We use temperature 0, so the agent's reasoning is deterministic and reproducible. The agent executor wraps the agent and runs the think, act, observe loop. We set verbose to true, so we can see the full reasoning trace in the terminal during development. Max iterations of 5 prevents an infinite loop if the model cannot find a satisfactory answer. Handle parsing errors set to true tells the executor to feed any formatting mistakes back to the model as an observation rather than crashing. The input question here requires 2 separate searches because refund policy and digital product policy are stored in different document sections. With verbose set to true, the executor prints every step of the agent's reasoning. We can see the model first searches for the general refund policy, reads the result, decides it still needs information about digital products, runs a second search with a more specific query, and only then synthesizes both observations into a final answer. This is the key difference from the fixed pipeline. The model ran 2 targeted searches with different queries instead of 1 broad search with the full question. Agentic RAG is not a replacement for the standard pipeline. It is an upgrade for specific cases. Use it when questions require information from multiple parts of your corpus, when the right retrieval query is not obvious from the raw user input, or when the task involves comparing or synthesizing across documents. For simple factual lookups, the fixed pipeline is faster, cheaper, and more predictable. Agentic RAG adds reasoning overhead in the form of extra language model calls for every thought and tool call step. You now know how the React pattern works, how to define a retriever as a tool, how to build and run an agent executor, and how to read a reasoning trace to understand what the model decided to retrieve. In the next episode, we build self-reflection loops, an agent that not only retrieves and generates, but also critiques its own answer and decides whether to improve